Hey guys, Kenna here. So today we're going to go ahead and do a quick review of some of the key concepts from term one that will apply here in term two. And then we're going to talk a little bit about net energy as we go ahead and start to look at our non-renewable resources in this unit, in particular our fossil fuels and nuclear energy. So let's jump right in. Our essential questions for today. Number one, what terms did we use last semester that will keep being utilized in second semester? Number two, what is the difference between the system and the surroundings? Number three, what is net energy and why is it important? And number four, what are examples of renewable and non-renewable energy? So some key vocabulary we want to make sure we have back in our pocket or in the back of our mind so that we can go ahead and utilize it over the course of this next term as well, include the following. Number one, globalization. This is a process of interaction and integration among the people, companies, and governments of many different nations. Number two, sustainability. The ability of Earth's natural systems and human cultural systems to survive and flourish into the long term future. Number three, and this is one that some of you had some trouble with in term one, so we need to make sure we understand this one can imply it. Full cost pricing. Pricing model that includes internal costs of production, which are already included, and marketing. Plus, this plus is the new part, the part that makes it full cost pricing versus what's currently being done. External costs to human health and the environment. So remember, the impact on human health and the impact on the environment are not currently included in the price that we pay for goods and services. So full cost pricing includes those. All right, number four, natural capital, the world's stocks of natural resources and ecosystem services. And while most of you were really good about remembering the natural resources part of this, we sometimes had a tendency to forget the ecosystem services, the things that the environment does for us. Plants, yeah, they're lumber. If we think about trees, we can use them to build with, but they also clean the air by converting carbon dioxide into oxygen for us to breathe. That is an ecosystem service. It's not utilizing the tree as a resource itself, but it's the service that the tree provides. All right, number four, number five, common pool resources. A type of good consisting of natural or human made resource where exclusion is difficult and overuse by one decreases the benefit for other users. And then lastly, perpetual resource. A resource that is renewed continuously, also known as inexhaustible. And the only one we have that's really good example of this is solar energy, because the sun is still there, sending out all of its energy towards our planet. There's some, arguments to be made with respect to wind, but with most of the other what we consider renewable resources, they're not perpetual because they're not really something you can run out. If used effectively, we can sustainably go ahead and continue to use them without diminishing what's available. But if you overuse them, the quantity and quality will decline. Okay. So when we start looking at these types of resources, we typically categorize resources into three categories. We have non-renewable, renewable, and perpetual. Remember that a resource is anything from the environment that meets a need. And in particular, we typically start looking at economic needs in terms of our ability to profit from that resource. So non-renewable resources are those that exist in fixed amounts. Things like fossil fuels can't be regenerated in a timely fashion, and so whatever we have is what we're going to be able to utilize until it's gone. When we start looking at mineral resources, these are another example of a non-renewable resource. Once you use up what's on the planet, that's it. That's all there is. Now, then we get into renewable resources, and these are probably the two categories that you dealt with maybe in middle school. Renewable resources are those that can be replenished fairly easily and rapidly. Trees are a good example of this. This is if used sustainably. Even with a renewable resource, if overused, if abused, okay, the quality and quantity of the resource begins to diminish and is no longer able to be replenished. This is different from the new one we introduced to you, which is a perpetual resource. This is one that is renewed continuously, and the only real good example I have for you of that is solar energy. Okay. Now, when we started talking about resources, another thing that came up was the tragedy of the commons, and we started talking to you about common pool resources. Now, hopefully, you remember this from when we had a bee's invoice and the video we watched on that. A common pool resource is a type of resource where exclusion is difficult and overuse by one decreases the benefit for other users. So, while in first semester we discussed common pool resources in terms of access to the ocean, the air, things like this, at its greatest extent, the earth is a common pool resource. And hopefully, our discussion of water in our previous units has emphasized this fact that all of it is connected, and you cannot really talk about one area's problems without really thinking about the impact globally. So, all facets of the human earth relationship relate to the health of the environment and it providing us with the resources we need to survive. So, when we start thinking about these resources, while we have a tendency to think about them very locally, there are very global impacts of those local changes. And so we need to think about these things in terms of the system versus surroundings. This is a concept from thermodynamics, something that when I teach it in physics has very real implications in terms of energy transfer and what a system can and can't perform. When we go ahead and take a look at system versus surroundings, the boundary must be very clearly defined so that one can clearly say whether a given part of the world is in the system or if it's in the surroundings. Now, if you're looking at the United States, that could be one system, and the boundaries of our country represent what we talk about in terms of the system. Everything else would then be in the surroundings. But as you saw in the previous slide, hopefully you realize that the Earth is the ultimate system here, and the surroundings are those things beyond our planet. Now, if matter and energy is not able to pass across the boundary, then the system is said to be closed. So, in terms of the United States, this is definitely not a closed system because we bring things in from all over the planet. Um, we start talking about globalism, right? Globalization has caused no system on our planet to really truly be a closed system. Okay, they're open. But Earth is a little easier to see as a closed system because it doesn't interact as much with the external surroundings in terms of the solar system, the universe, etc. So, when looking at the impact of a resource, its use, and pollution, the planet is for most purposes a closed system, but all other systems are open systems. So, if we're going to be looking at renewable and non renewable energy sources, we need to understand things in the perspective of this single system. And we start looking at a concept of net energy. And we need to understand what net energy is and why it's important. So, net energy is the total amount of useful energy available from a resource, subtracting out the energy needed to make the energy available to consumers. So, how much energy do we get from it? Minus how much energy does it take to produce? So energy resources vary greatly in their net energy. And so that's one of the things we need to keep in mind as we start looking at both renewable and non-renewable resources. What is the cost benefit analysis, if you will, when we go ahead and take a look at the net energy we get from the material? Only net energy really counts at the end of the day. Scientists look at net energy as the best measure for determining the long-term usefulness of an energy resource. You may have the most sustainable resource ever, but if it takes more energy to get that energy, it's not a feasible option. Okay. If a net energy is zero or a negative number, the resource cannot compete in the marketplace. And ultimately, most of these decisions made by corporations, made by individuals, are going to be based on finances, based on economics. And we need to be careful here when taking into account subsidies. If a resource is being subsidized to make it positive rather than zero or negative, it is still not an effective long-term sustainable solution. It may be very competitive in the marketplace because you're not paying the actual costs. And this is one of the reasons we start talking about full cost pricing when we go ahead and take a look at things like non-renewable resources, fossil fuels, solar, wind, etc. So let's take a quick look at some of the world's examples of renewable and non-renewable energy sources. So here is kind of an overview of what we'll talk about in terms of renewable energy resources. And we'll come back to these as we start looking at climate change and looking at all our alternatives to the heavy non-renewable resources that we currently have been relying so heavily on. So this includes things like solar, and that PV after it stands for photovoltaic. We've got geothermal, which is the internal heat of the planet. We've got solar hot water, biomass and biofuels, wind, solar space heating, and combined heat and power. We'll be a little bit more specific in terms of these different forms of energy, how they're produced, and what the net energy is to go ahead and utilize them when we talk about them more particularly. The ones that we rely on the most at this particular point in time are our non renewable resources. These focus on coal, nuclear fuels, natural gas, minerals, metals, and petrochemicals and oils. And so, especially for the United States, we've had a big history of natural gas, uh, coal, and our petrochemicals, our fossil fuels. And so, when we go ahead and take a look throughout this unit, we're really going to kind of focus on those fossil fuels as being a big part of that. We'll go ahead and start looking at that, especially on Thursday, as we go ahead and start looking at oil, fracking, etc. And then we'll go ahead and start looking at how those things play out in terms of, um, air pollution and what that leads to in terms of our ability to regulate the planet's temperature. Okay. All right. So that's what I've got for you guys today. Stay healthy, stay safe. I'll see you soon. Take care. Bye bye.